Alright students, this video is going to go over section 3.9. In the first video, we had gone over how to find the equation for these graphs. Okay, and it's different because at the beginning of the chapter, you're given the equation, you find the graph. Now we're just given a graph, and you have to find the equation. So watch the first video if you want to see that part. We're going to be going over a similar thing. Essentially, these are the same. Instead of even giving the graph, they gave you a table. Okay, this is not easy to do just by looking at it. We need some scratch paper. And finally, we're actually going to use Desmos to help us. The difference here is we're only given one x-intercept. We're only given 1, 0. That was the big key with the other problem. So given only 1, 0, we have to have another method. And we're going to need some scratch paper. So let's switch over. Now, this is already related to something you've seen before in Math 2 and 3. Something called sequences. That's a sequence of numbers right there. It's pretty basic. It's 2 to n. What it's doing here is each time it's changing by 2. Now, if you had, let's start with something a little bit tougher. 14, 19, 24, 29. That's also a sequence. And there's a pattern here. It's changing by +5, +5, +5. And so you know 5n has to be part of the equation. It didn't start with 5 though, so we also need an adjustment factor. Don't worry about that though. What we call these all is, these are first degree or first level differences. Okay. So most of what you saw in Math 1 or Math 2 was at this level. All right. We, of course, are stepping it up to the next level. Okay, so when you first look at this, excuse me, sorry. First look at this equation here, or sorry, the sequence here, it doesn't look like there's a pattern. Okay, I cannot tell a pattern. If I look from here to here, I can see there's a difference of 2, but this isn't 2. This is changed by 4. But then wait, this one changes by 6. But this one changes by 8. So the amount of change is changing. But wait a minute. At the first level, that's the first level, I don't see any different. I don't see any pattern. They're not all constant. If I go down to the next level, the difference between these is constant. So this is what we call the second level differences. And so we are looking for when they are constant. So we got to go down until we can find a pattern that establishes itself. So if you don't see the pattern first, go down to first level. You don't see the pattern at the second level, sorry, first level, go to second level. If you don't see it at the second level, you got to go to third level. And you can keep on going down levels, okay? We could have a 5th degree, any degree probably. So we're not going to get into that. We'll just step up to third. Our book will only go to third or fourth, okay? And already it gets a little bit tough, so we're going to need Desmos to help us with the last part. So let me create a sequence here for this example. So take a look at this one. This is our next example. You'll notice I don't see any pattern here. I cannot look at this and see a pattern. So we go down to the first level. Find the differences between all these. And by the way, if you have colors, it sort of helps as well. Because I like to see the levels. We're going to go down to the third level. So different colors for different levels would make it even more visual. All right. -1 plus 5 would give you 4. 4 plus 17 would give you 21. Already we got a weird pattern here. Now we're going to add 35. All right. And now, just to make sure I don't make a mistake, because last time I did it, and I was searching and searching, and I could not find my mistake in my equation. My mistake was right there in the basic math. So be careful with that, you know. If you make a mistake on the differences, you won't see the pattern, even though it's there right in front of you. So no pattern here. No pattern. That's first level. So we're going to go down to second level. 5 to 12 is plus, 5 to 17 is plus 12. 13 to 35 is plus 18. 35 to 59 is plus 24. And 59 to 89 is plus 30. Okay. Again, first level, second level. We still didn't see any patterns, so let me zoom this out a little bit. And at the third level, you should now notice there's a pattern. It's 6, 6, 6. Plus 6, plus 6, plus 6. The change is constant. That's what we need. So again, first level was all these. Second level was all these. This is the third level. Okay. We didn't solve what the equation is, but we know it's a third degree. We know we're going to be using something third degree plus some other stuff. I don't know what the rest of the equation is, and honestly, the methods take a lot of paper, so we're going to switch to Desmos right now. Okay, so I'm in desmos.com/calculator, and what you want to do, no, wrong button. Over here, you want to hit the plus, and you want to add table. This is where we're going to put in our table, and most of the ones in the book give you it as a table. And all I'm going to do is I'm taking our numbers that we put from here, 1, -4, so this will be the first one, second one, third one. So if we were going to make a table out of this, this would be our first term, second term, third term, fourth term, fifth term, sixth term. So we didn't have numbers for this, but this was the first one. This was our second term. This was our third term. So when we go to Desmos, we're going to go -1, 4, 21, 56, 115, and 204. Oh, we did have a last one. 6 numbers. Okay. So there's our table. Okay. You can see some of the points. Don't worry about too much. Put it here. So maybe it'll be a little bit darker. The table, here's what we have to do. We want it to match that table. Okay, so here's the key thing we're going to do. Our table is y1 and x1, so what we're going to do is go y1, and we're not going to put equals, we're going to put this squiggly. It's going to be approximately. That's the command for Desmos to approximate it. So if we wanted just a straight line, let's say just a straight line, AX is a straight line. The straight line won't hit our data very well. It's a very bad job, because we know it wasn't first degree. So let's put that to the third degree. Plus, we need something to the second degree. So be x1 to the second degree. And again, this x1 is just so it matches our table here. Because our table values were labeled x1. Okay. So we have an x cubed, an x squared, a c, sorry, just a regular x and a d. So x cubed, x squared, x, and then no x's. And our variables in front go a, b, c, d. Okay. And there it is. Wow. It hit all our points. Take a look. Take a look at that. It hit that point. It hit that point. Oh, these are some points that aren't even on our table. All right. But it is going through our... it won't let me click on the green point there. Anyway, I was trying to click on the green. There we go. Yeah. Well, anyways. There we go. If I hit the greens are on the table. I'd have to really zoom out for that. What the heck did it find for us here? A couple things. It found us the values of A, B, C, and D. Where you got to be careful is 10 to the -15, this calculator being a little bit doing calculator-y stuff. That's 0. Really, it's 0.00000000000. Do I have 14 zeros yet? No. Okay, well, it's 0.00000. It's so close, it's 0. It really is 0, so I apologize for that. So what you know is you don't have a B term, you don't have a D term. These are your A and A terms. So what the heck does that mean? Let's get all this off here. What it means is you can take all this and your equation can just be, your new equation, instead of A, I'm going to put 1, x to the third. We don't have a B. We do have a C as -2. There it is. So what we did right there, our A value was supposed to be 1. We had no B. Our C value was supposed to be -2. This equation now matches our data. This data is matched by this equation. We needed Desmos to find us those values. We needed Desmos to find us the A, B, C, and D. Now again, what the heck did Desmos do? Well, that's actually AP stats. That's statistics right there. These things right here, you'll learn about stats. Don't worry about it too much. Just understand the computer is running through a process that takes a lot of time, and it greatly simplified it for us by finding just these 2 values. And these we can ignore. All right, thanks for watching. Email me with any questions. I know this stuff's not the easiest, but Desmos is going to do some of the hard work for us. So thanks for watching.